All right, so we're going to start Chapter 2, Section 1, Linear Functions. So let's go over a few problems from this section. Got a feel for what's happening here. Terry is skiing down a steep hill. Terry's elevation, E of t, in feet after t seconds is given by E of t equals 3,000 minus 70t. So E of t, we could also say, when using function terminology, right? Elevation is a function of time. All right, so elevation is the output variable. T is, or time is the input variable. All right, so if I want to look at what's happening here, is that at time 0, the initial time, we're at 3,000 feet, and then it goes down or decreases because of the negative. I'm subtracting each time. So when I look at the next sentence, write a complete sentence describing Terry's starting elevation, how it's changing over time. I would say something like, starting at an elevation of 3,000 feet, Terry descends the hill at a rate of 70 feet per second. All right, so I look at this one. Maria is climbing a mountain. Maria's elevation, E of t, is a function of feet after t minutes, and is given by E of t equals 1,200 plus 40t. So again, elevation is a function of time, but this time, because the 40 is positive, that means that we start at 1,200 feet, and then we go up 40, so we're increasing it, we're getting bigger. So write a complete sentence describing Maria's starting elevation and how it's changing over time. The starting elevation starting at an elevation of 1,200 feet, Maria ascends the mountain at a rate of 40 feet per minute. But that's not a Maria, that's an Alex, a friend of mine. And when we took classes together, he was a math major, became a professional climber. Jessica is walking home from a friend's house. After 2 minutes, she is 1.4 miles from home. 12 minutes after leaving, she is 0.9 miles from home. What is her rate in miles per hour? All right, so the one thing you notice without even doing any calculations is that she's closer after longer amount of time. So that means that as the time increases, the distance decreases. That tells us that we should get a negative answer without even doing anything. I can tell that. So our input variable is time, because we want to have distance as a function of time. Our output variable is d. So the one thing we know is that anytime we talk about a rate, we're talking about slopes, right? So that means the change in the distance, because that's our output, divided by change in time, which is our input. And that's where we get this stuff right here, right? That's the change. Delta means change in distance divided by change in time. Now I just go up here and look at the two distances, and I look at the two times, and I just plug them in, right? So I have 0.9 minus 1.4 and 12 minus 2, and you can see we're going to get a negative answer like we thought. So half a mile per minute. Now, the reason this calculator is here is because whenever you do these expressions and you do a division, there's an unwritten parentheses here, which when you come over to the calculator to get the right answer, you have to include. Otherwise, calculators like this follow the PEMDAS stuff, and if you didn't have the parentheses, it would divide these two first, and then it would subtract off. So then you get the completely wrong answer. Sonia is currently 10 miles from home and is walking farther away at 2 miles per hour. Write an equation for her distance from home t hours from now. Now this one even says she's walking away at 2 miles. So this means that our slope would be positive. Now, the other thing you can think about when you do this is when you add things together that have units, those units have to match. So that means that 10 miles, which is how far she is away initially, we want to add to it some amount, and walking 2 miles per hour. But notice that the units per, which means divide, right, is not, they don't match up. Miles per hour and miles don't match. So what do I need to do? To add these two values, they must have the same units. Since we are asked to find the distance of the function, distance as a function of time, we need our answer in miles. So to convert this one to miles or change it to miles, I would have to multiply it by hours, because then these units divide out and I'm left with just 2t miles. Now the miles match up, and so therefore I can add the two together, and I get distance is equal to 10 plus 2t, where t is the time. Timmy goes to the fair with $40. Each ride costs $2. How much money will he have left after riding N rides? So this time we start with $40, but he's going to decrease. So that right there is an important word. He's going to decrease by 2 per ride. Again, the per, right? So that means that we have, it's a units that have dollars in the numerator. Dollars are weird units because they come in front of the number. Dollars per ride. So to get rid of it, we're going to multiply it by the number of rides, and we're going to get -2 because the word decrease. So we get -2n, which is our slope. So we start at 40 and we subtract off 2n, where n is the number of rides. All right, so this one, you just have to tell whether it's increasing or decreasing. And again, all you have to do is look at the slope, right? When the slope is negative, the linear function is decreasing. When the slope is positive, the linear function is increasing. So all we have to do here is look at -2. Since m is negative, we know that then the function is decreasing. 1/4 is a positive number, so then we know that the function is increasing. All right, this says, for the following exercise, determine whether each function is increasing or decreasing. So this is just a way to ask you to do the slope and then determine whether it's positive or negative, right? So I just take 2 points, difference in the y is divided by the difference in the x's, figure out that it's 4/5, which is a positive number, so it's increasing. All right, so for this one, for the following exercise, write an equation for the lines graphed. Now, kind of the key thing here is you need to know something about the graph, right? The first thing is that we know there's points that we can pick, right? Because they're easy to read. They go right through those little hash marks, right? So we have 0, 5, and 4, 0. Well, 0, 5 is the y-intercept. So I know then for my equation y equals mx plus b, I have b. b is 5. Simple enough. Now the other thing I really then all I need is the slope, m. Well, slope is rise over run. So if I look at the rise here, it actually is going down, which makes it negative. So it goes down 5 units and to the right 4 units. So that gives me a slope of -5/4 or -5/4, right? And then I just take my slope intercept form, y equals mx plus b, and plug in the m, plug in the b, and voila, I got the answer. All right, the last one here. At noon, a barista notices that she has $20 in her tip jar. Again, this is our starting spot, is the y-intercept, if you want to think of it that way, whatever variables you're using, right? And then, again, this is $50 from each customer. This is kind of a fancy way of just saying per, right? 50 cents or half $1 per customer. So this is the slope. So again, you're going to multiply this times your you're going to multiply this times your variable, or just realize that that's the slope. The other one is the intercept, and just plug them into the y equals ms plus b, and you have your answer.